In the previous video, we discussed how to find determinants of a 2 by 2 array or a second order array. In this video, we are going to discuss a 3 by 3 or third order determinant or higher. Now, to find a third order determinant, we can list out the formula, which is A1, B2, C3. And notice here that all of the A's are in column 1, all of the B's are in column 2, and all of the C's are in column 3. And that all of the subscript, and again, these are subscripts, they don't actually affect the number itself, they're just ways of labeling. The 1 items are all in row 1, 2 items are in row 2, and 3 items are in row 3. So this is a way of distinguishing. If we're in B1, then that means we're in the second column, first row, or first row, second column. So if we want to find the third order determinant, the first thing we have is A1, B2, C3 plus A3, B1, C2 plus A2, B3, C1 minus A3, B2, C1 minus A1, B3, C2 minus A2, B1, C3. And now you might be asking yourself, how am I ever supposed to remember this? Well, there's a couple of different ways you can go about doing it. One way is that the book talks about is to rearrange these terms based on their A terms. So for instance, if we look at everything that has an A1, then we'd be left with the A1 would have the B2 minus C3, B2 times, we have A1 times B2 times C3. We also have a minus A1 B3 C2, so we can put minus B3 C2. Now if we look at the A2 term, we've got B3 C1 minus B1 C3. And if we look at the A3 term, we've got B1 C2 minus B2 C1. Now this might not look like anything else at the moment, but if you notice, these really are determinants of 2 by 2 matrices in here. And this brings us to the process of using a minor. And so a minor, this method will work for any determinant larger than a 2 by 2. So if, for instance, we look at the A1 term, we cross out everything else in its column and its row, and we just take the determinant of the remaining pieces. So this becomes A1 times the determinant of B2, C2, B3, C3. And if you go back up here, that's what you have, B2 times C3 minus B3 times C2. If we look here, this one's going to be a little bit different, but if we circle the A2 column, we're going to cross out everything in its row and column, and we're going to be left with a determinant of B1, C1, B3, C3. Now if you notice, this is the opposite order of what we have here. We've got essentially the negative, so we're going to pull a negative out front so we can switch the order on those terms. And finally, if we look at the A3 term, cross out everything in its column and row, we end up with A3 times B1 C1, B2 C2. And again, in this case, this does work. B1 C2 is your first piece, minus B2 C2 is your second piece, so this is going to be added. And so this is the process of minors. It can be expanded to be bigger if you follow the rules with the signs. Essentially, anytime you take the first element, it's plus, and then alternate negative, positive, negative, positive. And like I said, you can do this for any size determinant. There's also a shortcut, which I'm going to show you on this next example, when it comes to 3 by 3 and only 3 by 3 matrices. And this shortcut involves repeating the first two columns, so 1, -3, 2, 1, 7, 1, and then looking at the diagonals. And we always start with that principal diagonal, again the one that goes from the top left to the bottom right of the original, and we multiply those three terms, so 1 times 7 times 5. Then we look at the next diagonal, 1 times 11 times 2. And we write that down. We add to that 1 times 11 times 2. And then we look at the next diagonal, -4, -3, 1. So we multiply those three together. -4, -3, 1. Then we look at the diagonals going upwards from the lower left to the upper right. So 2 times 7 times -4. And in that case, we subtract now as we go up. So we have -2 times 7 times -4. We go up the next diagonal, and we have 1 times 11 times 1. So we would have -1 times 11 times 1. And finally, we would look at our last diagonal going up, 5 times -3 times 1. And again, -5 times -3 times 1. And so this is a little bit easier to remember. So now all we have to do is simplify these products. So 1 times 5 times 7 is 35. 1 times 11 times 2 is plus 22. -4 times -3 times 1 is plus 12. -2 times 7 times -4 is plus 56. -1 times 11 times 1 is just -11. And -5 times -3 times 1 is positive 15. And then we take and we add all of these numbers together. And you should end up with a determinant of 129. Now let's try another example. I'm not going to draw the diagonals in this one, but we are going to start the same by repeating the first two columns. So in this case, our first diagonal is going to be 1 times 0 times -3 plus our next diagonal, which is 3 times -6 times -5, plus our third diagonal, which is 8 times 0 times 2. Now as we go up, we've got minus a -5 times 0 times 8. We have a -2 times -6 times 1. And the last diagonal we have is minus a -3 times 0 times 3. Again, simplifying, in this case, anything that has a 0 in it is going to multiply to be 0, so all four of those terms end up being 0. We're simply left with 3 times -6 times -5, which would be 90, and -2 times -6 times 1, which would be plus 12, and that gives us a grand total of 102 as our determinant. Now I want you to pause the video at this point and try example 6. So in this case, you should have found that the determinant ends up being 0, and we'll discuss why that is in the next section. Now, if we have anything larger than a 3 by 3 matrix, the shortcut that we talked about before is not going to work. And we either need to approach it as looking at minors, in which case you would probably just follow down one column and create the minors out of the remaining pieces, and then you'd still have to do a 3 by 3 determinant using what we've already talked about. The other way that we can approach this is by using our calculator. So go ahead and get your calculator out. Now, you need some type of graphing calculator to do this with. I'm going to use the TI-83. The 84 would follow a similar format. And what you do is you hit second, and then you should see here how it says matrix. And when you click that, you get the following screen. To put in a matrix, we're going to scroll over here to edit and select A. And then we have to tell it how big the matrix is. So in this case, you notice you have 4 rows and 4 columns. So we're going to 4, enter, 4, enter. And notice how now we have 4 rows and 4 columns. And we just go across, we read across each row as we go. So 1, enter, 3, enter, -7, enter, 2, enter. And we just keep going along the rows until we have all of those elements entered. And it's always a good idea to check. So in this case, my last column is 2, -2, 1, 2. Third column is -7, 0, 5, 7. Second column is 3, 3, -2, 1. And if we hit this arrow button over, we can see the first column, which is 1, -5, 1, 3. Now, a very important step is to make sure you hit second quit to exit out of this. Otherwise, we'll end up stuck in the matrix, and it gets kind of messy. Next, we're going to go back to matrix. This time we're only going to scroll over to math. And notice how the first thing here is DET, and that stands for determinant. So we're going to hit enter, and then we're going to go back to matrix. And now we're just going to stay in the names column because we actually want to select the matrix that we just entered. So you should see on your screen, it should say DET parentheses A, and it's in brackets because it's a matrix. You can close the parentheses, hit enter, and in this case we have a determinant of -138. So on this last example, I'm going to give you the option, if you have a calculator, feel free to use it and evaluate this determinant. Otherwise, do it by hand, but pause the video at this point and try example 8. So regardless of how you went about solving this, you should have found that your determinant was 0. And again, we'll talk about why this happens in the next section. But remember that anytime a determinant is 0, this means that you have a matrix that is non-invertible, which is something that you might talk about if you ever take a linear algebra class. So this concludes the video on 6.4. Please go online now and complete your homework for 6.4, and then watch the short video on 6.5.